Shivansh Electronics presents the MOTU M4 Technical Masterclass. 4 inputs, 4 outputs, reference-grade conversion that demolishes interfaces at twice the price. Let's dissect exactly why this machine redefines the standard. The heart of the MOTU M4 is the ESS Sabre32 Ultra DAC, the same conversion silicon found in audiophile equipment costing 10 times more. This is document 1 of our forensic engineering analysis. The ES9016S inside the M4 descends directly from the flagship ES9018, a chip powering $2,000 DACs. Every generation shares the identical hyperstream modulator and time domain jitter eliminator. The M4 inherits 123 decibel dynamic range from that same silicon bloodline. All 4 channels measure within 0.2 decibel of each other at minus 114 decibel THD+N mean. This is the golden sample standard. Shared silicon on a single die guarantees matched transfer functions. Channel variance this tight is physically impossible with discrete converter chips. The M4's loopback mixer internally routes your host mic, Zoom guest, and music bed into a single mix, all feeding OBS simultaneously. Mix minus capability isolates the guest return feed, preventing echo, while the full composite mix gets captured cleanly for broadcast. The M4 driver simultaneously serves 3 parallel streams, a SIO for your DAW, WDM for reference monitoring, and loopback for communications. A single driver manages concurrent sample rate negotiation across all 3, eliminating the audio engine capture conflicts that cripple lesser interfaces. Software monitoring routes through ADC, USB, DAW, USB, then DAC, accumulating milliseconds of delay. Direct monitoring bypasses this entire pipeline, tapping the analog signal before conversion. The input monitor mix knob blends both paths, giving performers phase-accurate, zero-latency confidence in their headphones. The Texas Instruments OPA1688 delivers 10 MHz bandwidth, 3.8 nanovolts per root hertz noise density, and 150 milliamp current drive with full rail-to-rail output swing. That current headroom drives low-impedance headphones with 0 distortion climb, all within the 2.5 watt USB bus power constraint. The SQNR formula combines bit depth, oversampling, and noise shaping order, with 5 quantizer bits 4th order modulation and 128 times oversampling. The ES9016S achieves a theoretical ceiling of 221.5 decibel. The M4's actual 123 decibel performance is limited purely by analog physics, not the digital engine. 4 independent channels, minus 129 decibel unloaded equivalent input noise, greater than 100 decibel inter-channel isolation, and 0.001% transfer function matching. This is engineering that reaches the boundary of what thermodynamics physically permits, then holds that standard across every single channel simultaneously. Sensitive in-ear monitors at 110 decibel per milliwatt expose every microvolt of amplifier noise. The OPA1688's 3.8 nanovolt noise density produces a calculated output noise of just 537 nanovolts RMS, translating to minus 123.2 decibel unloaded and a noise floor of only 1.6 decibel SPL. That is below the human hearing threshold entirely. At 85 decibels SPL listening levels, the M4 needs just 0.04 milliwatts. It delivers 340 milliwatts of reserve power. That 8/500 times headroom ratio ensures instantaneous transient peaks, like a snare drum attack, never cause microclipping, preserving every millisecond of dynamic impact. All 8 converters, 4 inputs and 4 outputs, share a single PLL master clock on 1 silicon die. Propagation delay matching stays below 100 picoseconds. Channel-to-channel deviation measures just 52 nanoseconds, which is 48 times tighter than the human hearing threshold for phase discrimination. Delta Sigma converters do not measure amplitude once. They sample millions of times per second, integrating the error signal through a feedback loop. The Sabre32 multi-bit modulator trades ultra-high megahertz sample rates for precise amplitude resolution, statistically averaging quantization errors out of the audio band entirely. Manufacturing variations in DAC capacitor elements create systematic distortion. Dynamic element matching rotates which elements are selected every clock cycle. ESS revolver technology extends this, rotating element usage millions of times per second, converting fixed mismatch errors into randomized ultrasonic noise that the decimation filter removes. Result, minus 114 decibel THD+N. The theoretical SQNR ceiling sits at 221.5 decibel. The 24-bit integer limit reaches 146.2 decibel. The M4 DAC achieves 123 decibel, and the ADC achieves 120 decibel. That gap is not a design failure. It is analog thermal noise, the irreducible physical limit of electrons moving through resistors at room temperature. Using the jitter SNR formula at 20 kHz with 1 picosecond of clock jitter, the Sabre32 delivers a jitter-limited SNR of 138 decibel. That is 15 decibel above the analog noise floor of 123 decibel, mathematically proving the clock is never the performance bottleneck. Analog circuit quality defines the M4's limits, not digital timing. 4 channels at 24-bit depth, 192 kHz sample rate, bidirectional, produces a maximum data load of 36.9 megabits per second. USB 2.0 supports 480 megabits per second. The M4 utilizes just 10.5% of available bandwidth, guaranteeing rock-solid stability and 0 dropouts under any operating condition. With Channel 1 at full scale, 0 decibel full scale, leakage into Channel 2 measures minus 100 decibel, just 0.001% signal bleed. That is 20 decibel below the noise floor of a quiet recording studio. Any bleed heard in a multi-mic recording is acoustic microphone positioning, never electronic crosstalk from the interface itself. The noise transfer function magnitude equals 2 PIF over Fs, raised to the modulator order L. This mathematical shape keeps the audible band flat at minus 140 decibel while pushing all quantization noise above 20 kHz. At the Nyquist boundary, noise attenuation reaches minus 135.1 decibel, leaving the entire audible spectrum completely pristine. Most engineers obsess over DACs and preamps, completely ignoring the final analog stage. The OPA 1688 headphone amplifier is where your entire signal chain either succeeds or fails. If this component distorts, every investment in microphones, plugins, and studio monitors becomes irrelevant before the sound reaches your ears. Headphones are reactive loads. Their impedance rises and falls with frequency. A high output impedance amplifier forms a voltage divider with that changing impedance, effectively applying an unwanted EQ curve to your mix. The M4's 0.05 ohm output impedance renders a ruler, flat frequency response regardless of which headphone model you connect. The headphone amplifier is the final gatekeeper in your signal chain, sitting between your DAC and your ears. In most budget interfaces, this stage is underpowered and high impedance. If it distorts or colors the signal, every expensive mic, plugin, and mix decision is compromised before you even hear it. From 16 ohm in-ear monitors receiving 403 milliwatts down to 600 ohm studio reference cans receiving 11 milliwatts, the M4 delivers adequate drive power across the entire professional headphone impedance spectrum. Every headphone load stays above the threshold required for accurate 85 decibel SPL professional mixing levels. The voltage divider equation shows that headphone voltage equals source voltage multiplied by headphone impedance over the sum of headphone and output impedances. With Z out at just 0.05 ohms, the denominator is effectively equal to the headphone impedance alone. The result is 100% voltage delivery completely independent of load, making the M4 a near-perfect voltage source. The M4 powers 2 preamps, 4 converters, phantom power, and a 340 milliwatt headphone amplifier entirely from USB-C. Dynamic power management allocates 434 milliwatts to the headphone stage, while the OPA 1688's efficiency ensures that specification holds firm despite serving double the converter count of the 2-channel M2. 4 verified specifications define the M4 headphone stage: 0.05 ohm output impedance for completely uncolored sound, 340 milliwatts to drive any studio headphone, a 1.6 decibel SPL noise floor for the most sensitive in-ear monitors, and fully independent monitoring control for professional session workflow. Trust your monitoring. Hear the source, not the interface. This forensic analysis covers microphone preamplifiers, the physics of silent amplification, thermal noise theory, gain architecture, and the 4-channel design of the MOTU M4. The core engineering objective is singular: reveal the sound from the microphone and do not create any sound of your own. Theoretical noise floor limit is minus 130.9 decibel unloaded. The physical gain knob position is read by the MCU, which sends SPI commands to the THD+N controller. The controller switches a precision resistor ladder network, changing gain in accurate 1 decibel steps. Audio never passes through the potentiometer itself, eliminating scratching, channel imbalance, and mechanical wear entirely from the signal path. A microphone outputs approximately 2.2 millivolts. The ADC requires 1.2 volts at +4 decibel unloaded. The preamp must magnify the signal by over 500 times, a gain of 54.9 decibel. The fundamental challenge is amplifying that signal 500 times without simultaneously amplifying the noise floor by the same factor. The theoretical noise floor sits at -130.9 decibel unloaded. The M4 measures -129 decibel unloaded. That gap is just 1.9 decibel, the hero gap. Of the total noise contribution, 80% comes from unavoidable source resistance thermal noise. Only 20% originates from the preamp electronics themselves. The preamp is effectively transparent. The Johnson-Nyquist equation states that noise voltage equals the square root of 4 times Boltzmann's constant times temperature times resistance times bandwidth. At 20 degrees Celsius with a standard 150 ohm microphone source across 20,000 Hz bandwidth, the result is 0.2204 microvolts RMS. That converts directly to -130.9 decibel unloaded. Below this, no amplifier can go. Physics forbids it. The Friese formula proves that noise in the first stage gets amplified by every subsequent stage. Total noise figure equals F1 plus F2-1 divided by G1 plus F3-1 divided by G1 times G2. The M4's preamp contributes just 1.9 decibel noise figure. Every downstream stage adds less than 0.01 decibel. Engineering budget placed exactly where the math demands it. The entire 2.5 watt USB budget is accounted for precisely. Digital and LCD consume 500 milliwatts. DAC and ADC converters consume 600 milliwatts. Preamp circuits consume 200 milliwatts. The remaining 1,766 milliwatts funds the DC to DC boost converter that steps 5-volt USB up to 48-volt phantom power at 87% efficiency, to condenser microphones powered with zero external supply. Both preamp channels maintain frequency response flat within plus or minus 0.1 decibel from 20 Hz to 20 kHz. THD+N holds at -114 decibel. Gain variance between channels stays below 0.5 decibel. Channel deviation in transfer function is less than 0.001%. Modern manufacturing tolerances eliminate the channel drift found in vintage discrete gear, guaranteeing perfect stereo imaging every session. The M4 is not simply a converter, it is a complete 4-in 4-out signal routing hub. A DC input pads, DAC output pads, internal routing buses, and digital input-output streams all converge through the MCU matrix. This architecture bridges physical hardware and complex software environments, enabling routing configurations that go far beyond basic stereo recording. 4 inputs accept microphone line and instrument signals from the front panel, plus 2 additional line inputs from the rear. All 4 pass through the ESS Sabre32 ADC and DAC core. The 4 outputs are DC-coupled TRS balanced, each independently addressable by the DAW. DC coupling means the M4 passes control voltage signals directly, making it fully compatible with modular synthesizer systems. The routing matrix allows any input to reach any output simultaneously. Analog inputs 1 through 4 and USB returns 1 through 4 can be mixed to the main outputs 1 to 2 for the engineer, while a completely independent aux mix feeds line outputs 3 to 4 as a dedicated talent monitor feed. Both mixes are captured simultaneously to USB sends for multi-track recording. Loopback routes DAW output audio back to a virtual input class entirely within the digital domain, bypassing the DAC and ADC converters completely. The internal loopback bus carries the signal with 0 generation loss and 0 additional latency. Recording software captures computer audio and live microphone input simultaneously, with no physical patching required. Round-trip latency equals buffer size divided by sample rate, multiplied by 2, plus USB transfer overhead. At 32 samples and 48 kHz, the calculated latency is 1.33 milliseconds. Real-world ASIO measurement shows approximately 2.6 milliseconds, with the 1.3 millisecond gap representing USB isochronous transfer overhead and converter pipeline delay. Below 5 milliseconds is perceptually transparent for live performance. Outputs 1 and 2 via TRS feed, Zone 1 the control room near-field monitors. Outputs 3 and 4 via RCA feed the headphone amplifier for Zone 2, the vocal booth. Each zone carries an independently mixed signal. Phantom power for a condenser microphone draws 48 volts at 10 milliamps, consuming 0.48 watts of the USB budget per channel. On Mac OS and iOS, the M4 operates as USB class compliant with zero driver installation, routing through Core Audio natively with full 4-channel I/O on iPad via USB-C. On Windows, the MOTU Generation 5 driver enables ASIO and WDM simultaneously. Shared clock synchronization across all 4 channels maintains phase coherence within 0.01 milliseconds on both platforms. Many competing interfaces drop to 2-in, 2-out at high sample rates to stay within USB bandwidth limits. The ESS Sabre32 Ultra architecture maintains full 4-in, 4-out channel availability at 44.1, 48, 88.2, 96, 176.4, and 192 kHz. No channel count sacrifice at any sample rate. This is a direct consequence of the ESS Silicon's efficient multi-channel conversion design. Smaller buffers reduce latency, but demand more frequent CPU interrupts, risking dropouts under heavy plug-in loads. Larger buffers increase stability, but add delay. The latency and CPU load curves intersect at the stability sweet spot of 128 samples at 48 kHz, delivering approximately 7.2 milliseconds round-trip latency with reliable dropout-free performance across 4 simultaneous channels. The M4 is not just an interface with more holes. It is a full signal routing matrix delivering any input to any output, independent Q mixes, hardware inserts, A/B monitoring, broadcast-ready loopback, and less than 0.21 microseconds of phase error across all 4 channels. Professional routing architecture at $269. Document 4 covers build quality and metering. Professional audio gear is defined by 2 things: how it handles the signals you cannot see, and how accurately it presents the ones you need to see. This section examines the physical architecture, electromagnetic shielding design, and visual feedback systems of the MOTU M4. The PCB is divided into 2 physically separated zones. The analog section maintains a -129 decibel unloaded noise floor on its half. The digital and USB section occupies the other. Trace separation exceeds 5 mm between zones. Capacitive coupling across that boundary measures below 0.15 picofarads. A single star ground point ties both sections, eliminating ground loop interference. The 6061T6 aluminum alloy chassis functions as a Faraday cage, providing greater than 200 decibel total shielding effectiveness. Absorption loss through the aluminum wall exceeds 170 decibel across the 100 MHz to 1 GHz range. Wi-Fi, Bluetooth, and cellular signals from surrounding devices are blocked before they can reach the analog circuitry inside. The M4 is the only interface in its class with high-resolution full-color metering across all 4 inputs and 4 outputs simultaneously on a 160 by 120 pixel display. Color transitions from green through yellow to red give instant visual confirmation of signal level. A dedicated clip warning indicator catches digital overs before they corrupt a take. The M4 meter displays peak ballistics with 0 millisecond attack, catching every digital over instantly. The secondary RMS display uses the formula square root of the mean of squared samples, integrating over time to show average power and perceived loudness. Seeing both simultaneously lets the engineer distinguish transient clipping danger from sustained loudness in real time. The decibel full scale sets 0 at the digital ceiling where clipping begins. The M4 meter is calibrated, so green represents the nominal operating level of -18 decibel full scale, which is the optimal headroom target for most DAW plugins. Yellow is the warning buffer, red means the signal has hit the digital ceiling and distortion is occurring. Green is good, red is dead. USB 2.0 delivers a maximum of 2.5 watts at 500 milliamps. The M4 consumes exactly that full budget, fitting 2 preamps, 4 converters, a backlit LCD, and a headphone amplifier into that constraint. Achieving this required a DC to DC conversion efficiency of 92% across the internal boost converter, leaving 0 margin for wasteful power design. The 6061T6 aluminum chassis acts as the sole cooling system. With a thermal resistance of approximately 10 degrees Celsius per watt and a total dissipation of 2.5 watts, the chassis surface reaches roughly 50 degrees Celsius above ambient. That warmth you feel on the chassis surface is heat being pulled away from sensitive clocking and converter chips by design. Phantom power consumes approximately 1,200 milliwatts, the largest single allocation in the budget. The ESS DAC and ADC together consume 600 milliwatts. Preamps draw 200 milliwatts. LCD display consumes 100 milliwatts. The headphone amplifier draws 200 to 440 milliwatts dynamically. MOTU's dynamic power management throttles non-essential subsystems during peak phantom draws, preventing USB bus resets. The USB-C port is rated for over 10,000 insertion cycles. Gold-plated XLR combo jacks withstand over 1,000 connection cycles without signal degradation. The TRS quarter-inch jacks and gain potentiometers are rated for over 20,000 rotation cycles. The most mechanically stressed components are built to outlast the computer they connect to, all within a compact, high-density desktop footprint. Laptop USB power lines carry switching noise from internal regulators. The M4's internal power isolation stage filters this before it reaches the analog section. Balanced TRS output architecture then rejects any remaining common mode noise by transmitting the signal on two conductors in opposite polarity and subtracting them at the monitor input. The result is the -129 decibel unloaded noise floor, preserved even with a noisy USB source. The final section of this forensic analysis covers competitive positioning. The MOTU M4 is evaluated across three dimensions: value engineering, component superiority, and market placement. The question is not whether it competes in the sub-$350 category. The question is whether anything else in that category competes with it. Across all six performance dimensions, the M4 dominates its class. DAC dynamic range at 123 decibel, a DC dynamic range at 120 decibel, headphone power at 340 milliwatts versus the category average of 40 milliwatts, full 4-channel count retained at all sample rates, 6061T6 aluminum build quality, and price efficiency that delivers all of this at $269 US. The M2 is the entry point into the MOTU ecosystem. Every product in the lineup runs the same unified ESS Sabre32 audio quality baseline. Upgrading from the M2 at $199 to the M4 at $269 and then to the M6 at $449 adds expanded input-output. The ultralight MK5 adds onboard DSP processing. The 828 becomes a full studio hub. Skills and sessions transfer seamlessly across the entire ecosystem because the conversion quality never changes. Best audio in class at 123 decibel DAC dynamic range. Best headphone power at 340 milliwatts. Best visual feedback with full color LCD metering across all 4 channels. The MOTU M4 is not just an alternative to other interfaces at this price. It is a higher class of engineering sold at a competitive price. Available now at Shivansh Electronics. That's the MOTU M4. 4 channels of reference-grade engineering that redefines what's possible at this price point. Shivansh Electronics is the authorized distributor of MOTU audio interfaces in Eastern India. For detailed technical assessments, performance analysis, or any queries about the MOTU M4, reach out to us at our Kolkata showroom. For the best deals on any audio interface from MOTU, Mark of the Unicorn, a renowned USA-based brand celebrated for its precision-engineered audio interfaces, reach out to us directly. Call us on the mentioned mobile numbers, which are 983-1662458 or 898-18-07755 or 914-770-0677. Follow us on Facebook and Instagram at shivanchelectronics.in. Follow us on LinkedIn and subscribe to our YouTube channel at Shivansh Electronics-in and hit the bell icon for notifications on professional audio insights and technical masterclasses like this one. All links are in the description below. Thanks for watching. We'll see you in the next video.